So this session is session 5, Lighting Policy Guidelines and Innovation. We're going to have two presenters, so put your questions in the Q&A, and we'll get to them after both presenters present. So our first presenter, Leora Radetsky of DesignLights Consortium. Um, Go ahead.
Great. Can you see my presentation screen?
That's good.
Perfect. Okay, so I will get started. Thank you, Mark. Hi, everyone. My name is Leora Radetsky. I work for a nonprofit called the DesignLights Consortium, or DLC. I am both a senior lighting scientist at the DLC and the program director for Luna, which focuses on programmatic solutions for dark sky friendly, energy efficient outdoor lighting. I'm also the co-chair of the BCPA Lighting Working Group alongside Joanna Ludmerding of Fish and Wildlife Service. And today I'll be introducing you at a very high level, because we're short on time, to lighting policies and guidelines that support, but don't guarantee, bird-safe nights on a budget. While the DLC is well known in the energy efficiency world, it's probably less well known to you. We are a nonprofit, and we provide decision makers with tools to reduce energy consumption, carbon emissions, and light pollution. Before I get into the details, I want to share a few basic definitions for lighting terminology. First, when we talk about the total light output of a source, like a light bulb or a light fixture, we'll use lumens. While you may have heard people talk about light bulb performance in terms of watts, like a 100-watt light bulb, that is not the right metric. Lumens weigh the total light output in terms of the human response. You'll also hear often about CCT, or correlated color temperature. This describes the color appearance of a light source, or its hue. The units are given in degrees Kelvin, and for reference, the CCT of an incandescent lamp is 2700 K. Next, you'll hear a little bit about bug ratings. These are a prescriptive rating system from the Illuminating Engineering Society, or IES. They represent a light source's optical distribution pattern in terms of 3 classifications: backlight, or B, uplight, or U, and glare, or G. A luminaire with 0 uplight has a U0 rating. And finally, you'll hear a little bit about lighting zones. Lighting zones are exterior environmental zones where lighting is expected, and these zones set programmatic constraints on the attributes of exterior lighting. I like to think about lighting policies and guidelines with a sticks versus carrots analogy. When we require end users to do something, we need to use a figurative stick, and these sticks are codes or regulations. The primary ways that outdoor lighting is regulated in the US and Canada is with energy codes and with state or local ordinances or bylaws. In the US, we have 2 model energy codes, ASHRAE 90.1 and the IECC. These codes are updated on a 3-year cycle. And state energy codes, like California's Title 24, shown here, often adopt the provisions of the model energy code. Local ordinances and bylaws are implemented by thousands of municipalities, as well as many states. And we want to encourage or reward end users for doing the right thing, or allow them to differentiate. We use carrots. For example, to encourage additional energy savings, energy efficiency programs and utilities provide rebates and incentives. My organization, the DLC, writes voluntary technical requirements for LED lighting that allows utilities to offer rebates. Other carrots include recognition for participation in voluntary programs like Lights Out campaigns, Bird City Network, LEAD, and WELL. And there's probably others you can add in the chat. So energy codes set a floor for minimum energy efficiency and controllability. This map is from DOE, the Department of Energy, and it's updated as of September 30th, 2025. It shows the energy code adoption in each state by code year. Energy codes are written with 2 goals in mind: energy security and cost effectiveness. In practice, this means that code measures must have a meaningful impact on energy reduction at scale and save the end users money. The metrics that are used to drive down energy use are lighting power densities. This is the maximum wattage that can be installed by lighting per square foot, and switching or dimming requirements during nighttime hours when occupancy is expected to be low or non-existent. This figure from DOE shows you when each state in the US adopted newer energy codes for commercial buildings. Now, there's a lot of information here, so don't worry about reading it all. I want you to take away two pieces of information. First, that older energy codes can be adopted long after they are replaced by newer energy codes, and they can stick around for long periods of time. And second, that states don't have to adopt the model energy codes verbatim. They can choose to amend the code and weaken or strengthen it. This is indicated by upward and downward tilted arrows in this figure. Energy codes do save end users energy and money. This figure plots the code year on the x-axis and the lighting power density, or LPD, on the y-axis. Lower lighting power densities indicate that less installed lighting power is required and used. And as you can see in this figure, all the lines are going downwards, indicating that reductions in installed lighting power are occurring with newer codes. Lighting zones were adopted in 2010, and LED adoption was mandated in 2016. And these are responsible for the 80% reduction in lighting power we see for parking lots today compared to 2004. Now, there are a few big challenges with energy code adoption. First, end users only need to meet their state energy codes when significant alterations are made or for new construction. In practice, it means that minor upgrades are often made in order to avoid code requirements and significant investment. Second, enforcement is a significant challenge for energy codes like it is for ordinances. And third, energy codes focus on energy savings. So other improvements like light pollution minimization may be important to some energy codes, like state codes like Title 24 in California, but not to all codes. Modern energy codes also require that controls are used for exterior lighting. The timing and exact requirements varies by application and by the adopted code. In ASHRAE 90.1, for example, nighttime dimming for parking lots began to be required in 2016 codes with the adoption of LEDs. Prior to that year, the lights could be on all night long. As of 2016, the code requires that for parking lots, lights are dimmed at least 50% for midnight or 1 hour after the business closes until 6 a.m. So beyond energy code requirements, lighting rebates, as I mentioned before, provide a monetary mechanism for reducing energy use and light levels further. Utilities and energy efficiency programs in most states in the USA and many provinces in Canada offer lighting rebates for energy efficient lighting. And for lighting controls, rebates are a great way to entice end users to upgrade their first generation LED lighting systems, which often have high CCTs, or their older technologies to dark sky friendly LED systems. If you're not talking about rebates in conjunction with dark sky friendly lighting, you are leaving money on the table. Luna is DLC's dark sky program, as I mentioned before, and we have incremental lighting quality requirements for outdoor lighting to be listed. Because all lighting products, all Luna products are also DLC listed and meet rigorous energy efficiency requirements, they qualify for these often generous lighting rebates. Now let's look at ordinances. Ordinances can be simple or complex, but many lie right in the middle. So simple ordinances use prescriptive metrics like maximum CCTs or bug ratings, and others shown on the slide on the left. The advantages of these prescriptive metrics is that they're easy to report and easy to enforce. The disadvantage is that they don't take into account the variations in outdoor lighting geometries, especially in retrofits. It's not unusual to end up underlighting or overlighting a site to meet these prescriptive ordinance requirements. On the other hand, an ordinance with performance-based requirements is complex to meet both for the specifier and for the regulator. Performance-based ordinance language may have spectral requirements beyond CCT, maximum illuminance thresholds, and bespoke dimming requirements. They can be easily implemented by subject matter experts who know what they're doing, but they typically require more specialty tools for design and enforcement, and as such are more expensive and more complex to enforce. If you're interested in crafting ordinances, choosing between a simple or complex ordinance then is a matter of precision, accuracy, budget, and training. There are advantages and disadvantages, frankly, to both types. In practice, most ordinances are somewhere in between. This ordinance from a city closest to me in Albany, New York, has a mix of both prescriptive language, highlighted in yellow, and performance-based language, highlighted in blue. It's also using a lot of deprecated terms and older technology requirements, which means it's very hard to know what to do for modern LED lighting. Now, if you're looking to see what your local ordinance requirement is, or looking to some local ordinances for inspiration, here are a few comprehensive resources you might want to check out. On the left is a map available on the General Codes website. This is free, and you can search for digital codes by typing in a city name or searching by state. On the right is a map of outdoor lighting ordinances hosted by the DLC. This free resource has about 1,000 ordinances today, roughly a third of the existing ordinances that are out there. Now, there are several model ordinances available online that you can use as samples. I'm showing a couple here, but there are also others out there, including one from Lights Out Connecticut and another one from Massachusetts DarkSky. The two model ordinances I'm showing here illustrate the range of complexity that you may want to consider. DLC's sample ordinance relies on prescriptive requirements. DarkSky's municipal ordinance template has both prescriptive and performance-based requirements in it that requires more subject matter expertise. And finally, I want to stress that we have a lot of knowledge gaps with regards to bird safe or even bird-friendly lighting, if that even exists as a thing. Lighting is first and foremost designed for humans, and our lighting systems are designed for human visual performance in mind. While energy codes and ordinances consider and constrain light levels to some extent, they are not often designed with other taxa as a priority. We don't know how much light is too much light for birds. We understand that we should limit blue-violet light outdoors to limit sky glow, but LEDs are available now in many warmer colors. Are any of these less attractive to or less disorienting to birds? What are the implications for using these newer products on energy codes and on end user power bills, especially in localities with constrained resources? Are the dimming requirements that are included in codes and ordinances sufficient to minimize bird attraction or disorientation? Or does the lighting need to be switched off completely to make a difference? Are there hours that are more important than others? And finally, all LED drivers modulate light output either at 60 Hertz or at higher frequencies. How do these frequency choices affect bird behavior? And would higher frequency designs benefit birds? The BCPA Lighting Group is working on a few deliverables this year and next for the benefit of our Alliance members. First, we're finalizing a lighting FAQ for non-lighting experts. And second, we're beginning work on a presentation deck for lighting professionals that shares information on the known lighting impacts on birds. If you'd like to join the lighting working group, please let us know. We'd love to have you on board. Here are the references for the figures that I showed in my slides. I'll pause here for just a moment so you can take a screenshot if you'd like. And thank you very much for the opportunity to speak. This is my contact information. I will answer questions at the end of the session and be available for the breakout if you'd like to attend. And I'm happy to have a phone call or a meeting to discuss more. And I will pass it back to Mark. Thanks, y'all.